Hey, Trunkhale here. I'm going to introduce you to the E over M equipment that's going to utilize the Classen method for determining the charge to mass ratio of an electron. So we're going to start with some of the equipment that's connected to this E over M apparatus. We'll start in the back. This power supply here is going to be the supply that goes to our filament, which is going to make glowing hot metal, all right, which is going to be near a plate that's going to be at a very high potential, and that's going to draw electrons off of that very hot filament. So Majid, if you can point at our ammeter that's connected to that power supply, you're going to see when I first turn this on, I'm going to be sending a constant voltage into a resistance, which is going to give us a current, and as that filament heats up, the resistance is going to increase, so you're going to see that we're going to get a very high current, but then as the resistance increases, our current is going to drop to some stable amount, and we're just going to leave it set at that for the rest of the experiment. This large power supply here is connected to our Helmholtz coils, which is going to go ahead and create our magnetic field, which is going to bend the beam of electrons. If you want to come around to the front, the controls for this supply are here. You're going to see that there's a few values that you can set. The only thing you're going to be worried about setting on this power supply is going to be the current, and this will be the current going through the Helmholtz coils. All right, two other supplies. This power supply here is going to be used for our grid voltage. This is going to help us narrow and sharpen the beam of electrons after they pass through the ring inside of our tube. And then finally, we're going to have our cathode voltage, which is going to be used to accelerate the electrons. And that control, you're going to want to make sure that this switch is turned on, and then you're going to utilize this knob to control the voltage, which will be displayed at this voltmeter. So you can see as I lower that voltage, the voltage on the multimeter changes as well. So to take a bit of sample data to show you how this works, I'm going to set this back at 150 volts, which is going to be the max voltage for this experiment. And what you're going to be doing is you're going to set it at a max voltage and then decrease that voltage by 5 volts every time. And at every voltage, you're going to change the magnetic field that's going to the Helmholtz coils to get a different beam radius on our electron beam. So I think we're going to go ahead and do a demonstration just to show you what's going on. So Declan, if you could go ahead and turn the lights off. What Majid is going to be showing you is going to be the plate in which the electron beam is going to strike. So actually, Majid, if you want to look at me, here's an example of that plate. You're going to see that there's concentric rings around the center opening where the electron beam is going to be coming from. Our goal is going to be to change the magnetic field such that the beam strikes the circumference of one of these circles. So we're just going to show you what that's going to look like on our actual apparatus when the electron beam is on. If I hit the standby button to turn on the power supply for the magnetic field, you're going to see a green spot appear. If I start increasing the magnetic field, you're going to see that I could get that beam to land directly in the middle of that line. Now what you're going to want to do if you want to switch the direction is you hit the standby button to turn off the field, then move the switch so it's towards you, and then if I turn the standby button on again, you should see the field has changed direction, so the beam has switched directions 180 degrees. All right, Majid, if you could turn the lights on real quick. The rule for these Helmholtz coils right here is that if you can hold your hand on them for 5 seconds and not burn yourself, you're probably good. But if it's any hotter, you're going to want to make sure to turn them lower. You don't have to be J.J. Thompson to know that.